In this video, I will show how to find the surface area of a solid of revolution. And before we start, let's recall the formula for the surface area of a solid obtained by revolving a piece of a function on the interval from a to b around the x-axis. The formula is integral from a to b y times square root of 1 plus derivative of f squared dx, where y is the function. Now, when we revolve around the y-axis, let's assume that in this case we have a function x as g of y on the interval from c to d, then the formula changes a little bit. We have an integral from c to d of g of y times integral 1 plus g prime y squared. In this case, we're rotating around the y-axis, so we have to use the second formula. That means whatever function we have to rewrite it in terms of y. So y equals x squared means x is equal to square root of y, and since we are in first quadrant, we're choosing the positive radical here. So my function g of y is square root of y. The limits of integration will be from 1 to 9, since we're integrating with respect to y, and the integral therefore will be from 1 to 9 of g of y times square root of 1 plus, and derivative of g is 1 over 2 square root of y squared dy, and the rest is just integration. Although I forgot to multiply everything by 2 pi in the front, but that's just a constant and doesn't affect the integral. So let's continue. We combine the two radicals in the integrand to obtain the following expression, and we're going to find the antiderivative of this as y plus 1/4 to the power 3/2 times 2/3. The limits of integration are from 1 to 9, and plugging it in gives us the following. So we have 4 pi over 3 here, plugging in 9, that's 37 over 4 to the power 3/2 minus plugging in 1, that's 5/4 to the power 3/2. Now this expression can be simplified just a little bit, so we can apply the power 3/2 to the denominator 4, which will become 8. So reducing that 8 with the 4 in the numerator gives us pi over 6, and here we have 37 to the power 3/2 minus 5 to the power 3/2, and this is the final answer for the surface area of the solid of revolution.